Calorimetry, very, very, I would like to say one of the mm, one of the underrated practicals. So using calorimetry to find out how much heat is given out by a reaction by measuring temperature change. Finding the enthalpy of combustion of a flammable liquid, where we first burn a calorimeter. As the fuel burns, it heats the water, then we can work out the heat energy absorbed by the water. Ideally, all the heat given out by the fuel as it burns would be absorbed by the water, therefore working delta enthalpy of combustion exactly. But that's not the case. Lose heat loss. If it's what's it called? It's a incomplete combustion, and we lose heat then. And during the experiment, therefore, we need to record the temperature at regular intervals beginning a couple of minutes before you start the reaction. Plot a graph of results and draw two lines of best fit, one through the points before the reaction started and one through the points after the reaction started. Then we need to extend both lines so they both pass the time when the reaction started. The distance between the two lines at the time the reaction started is the accurate temperature change. Calorimetry can be used to calculate enthalpy change for reactions that happen in solution, for example, neutralization, dissolution, displacement. Now, finding the enthalpy for a neutralization reaction, we add a known volume of acid to an insulated container and measure the initial temperature. Add a known volume of alkali and record the temperature of mixture at regular intervals over a period of time. Then stir the solution to ensure it is evenly heated, and then find a temperature change in experiment using the graph method. And we can calculate enthalpy change, and that's the graph method. Plot graph results, two lines best fit, one to points before reaction started, one to points after reaction started. Extend both lines so they both pass the time when the reaction started. Distance between two lines at the time reaction started is the accurate temperature change. That's the graph method. And here's another one. The energy change per mole of reactant, the formula for that is moles equals concentration times volume. So yeah, just so you're aware, obviously that everyone should know that moles concentration volume, but it could just ask you find this and find the enthalpy change per mole of reactant, and that's really all that's saying is find out this. But you might, if you've never seen this before, then you're probably going to get confused.